Okay, so I'm Kooper, and I'll talk today about simple extractors. But before that, I think I want to go quickly over. This was the slide that was supposed to give me an overview, so I'm going to skip that because this is the wrong slide. Basically, I'll talk a little bit about. Want to give you a little bit more information about what is an extractor, and before, just to make sure that we have the same information when we start talking. An extractor, the name extractor that we talk about comes from the fact that we have pieces of code that are responsible for extracting information from data. So when data is uploaded in Clowder, these extractors will extract information from this data and basically bring it back to Clowder so it becomes available for other people to look at, search for, etc. Right now, there's different ways these extractors can get triggered. So you can upload. It can happen when you upload a file, when you add files to data sets, metadata is added to a file or a data set. When a user manually triggers these extractors, so you can actually manually go and start these extractors. Extractors can have parameters passed in, so this is what you can use to change the behavior of the extractor slightly. It should not be too drastically, but you can change it slightly. The extractors can be grouped together. I forgot the exact terminology that we're using for this. This is a new feature that will be released, I believe, in the 1.8 release of Clowder. Yeah. And extractors have a single file to describe them, which is the extractor info.json, and I'll go a little bit more into detail. So this is a little bit, gives you a little bit of information about what is an extractor, what they do, etc. Here's some example extractors that we have. If you upload an image, it will extract the EXIF information from it. You can see that on the right. That shows you all the information that is embedded in the images. If a person uploads an image that has text embedded in it, we have an OCR extractor that will actually find the text embedded in the image and extract it from the image and return it from you. Faces that are in images, it will automatically find the bounding box and extract little preview images of these of the faces. Extractors are also used to create previews of the data. So, for instance, on the lower right, you can see a preview of a audio file that was uploaded. So instead of just showing you the subsampled potentially version of the audio, it can also be used to basically generate a visual representation of something that is not an image. So in this case, the audio. It can also be used to extract information from a group of files. So if I have a data set with many files or a collection with many files in it, I could potentially write an extractor that takes all the images, looks for the geospatial information in those images, and says all these images are located around this area on a map. And so I can use that to basically give you a bounding box of where all these images are. How extractors are called? Their extractors are triggered by Clowder. Clowder will send a message on the message bus. In our particular case, we use RabbitMQ. It contains the data to connect to Clowder, so the URL as well as a password if needed. To connect to Clowder, and it contains the data that needs to be operated on. In this particular case, it could be the file name, it could be what triggered it, etc. So it's a very small message, but it has enough information in there for the extractor to know why is it started and how do I get to the data. Extractors should only process their own messages, so they should listen on their own queue. You should not have two different extractors listening on the same queue, and I'll show a little bit how we try to avoid that from happening. That being said, right, if you have multiple image processing that do the preview generation, they can all listen to the same queue because they basically process these messages in parallel, so you can speed up the process there. And I think an important thing is that the extractor should not remove a message from the queue until they're finished. Like that way, if the extractor stops, crashes, or some other way does not finish its job, the message gets automatically put back on the queue, and then the next version, the next iteration, it gets picked up by somebody else, and they might process it correctly all the way to the end. So that way, we're guaranteeing you that the message is always finished by the extractor and correctly processed. So I went a little bit on the extractor, and so the next step is basically let's create one. It's simple. Right? You find the RabbitMQ software, you connect to it, you listen for the message, you process each message, You inform Clowder, you started downloading the data, you download the data, you inform Clowder, you started processing, you process the data, you finish uploading the data back to Clowder, you inform Clowder, you finish processing, and you remove the measurement queue. That's actually a lot of work. And really, this works. Right? If we've had people that do all this, and it's like once you've done it, it becomes a lot of boilerplate, and you're used to it. But it's still a lot of work. And so what we want to do is take some of this complexity out of it. So the first step that we did is we created PyClowder. It simplifies creating the extractors. It's written in Python. It actually supports both Python 2.7 and 3. It will basically, for you, create the connection to RabbitMQ, and does most of the grunt work that I listed in that previous slide. It has functions to interact with Clowder, so instead of you actually having to call Clowder manually, using whatever library you want to use for that, you just call a function, and behind the scenes, that function will actually connect to Clowder and does this. The way to do this is you extend the extractor class that is defined in PyClowder. You implement this process file function inside the extractor class, and you give an extractor info to JSON file. Now, this is the second time I talk about extractor info to JSON, so let's go a little bit more detail in there. On the right side, I'm not sure how clear that is to see, is an example of the extractor. In the slides, when I upload them, I'll make sure that the background is not black and the colors are not pretty, so it's actually easier to read them. You need to give it the name of the extractor. In this particular case, it's NCSA word count. This is used as the queue when sending a message, and it should be unique. And so we use sort of a Java-esque way of making this unique by prefixing it with our specific company. So in our case, all our extractors will pretty much be prefixed with NCSA. In the case of one of our other projects, the TerraRef, all the extractors are prefixed with Terra. And so that way we are sort of having our own namespace for these extractors. Each extractor should have a version number. This is important so that you know exactly which version of the extractor was used to extract it as information. When the data is uploaded back to Clowder, it actually will attach to it the name of the extractor and the version that was used to extract that information. Authors and contributors, to me, this is very important because we want to make sure that everybody gets credit for what the work they're doing. And then there is the context section, and this is the list of the metadata returned by the extractor. Right now, we're not validating to make sure that you're actually only returning in Clowder the metadata that you list there in the extractor info. In the future, this might become a requirement. Now, for the simple extractor, this is used. And so for the simple extractor, having this context listed there correctly is very important. And I'll show you later more. And then finally is the process section at the bottom, which is the how does this extractor should expect to be triggered. So in this particular case, it should be triggered on all text files as well as on the application JSON. So this sort of gives you a little bit of a very fast overview of the extractor info. So let's go back to PyClowder. So here's the list that we had before, and notice how all the things that are stricken out are basically taken care for you in PyClowder. And now all you're left with is process data and uploading data back to Clowder. So this basically takes care of a lot of the boilerplate that we have. So if we look at it, here's an example extractor. You can look at it, it has the process message, it extends the extractor class, and you can call functions to upload things back to Clowder. So this makes life a lot easier for people to start to write extractors. Notice how the very first extractor example I never showed, because that would basically have to include the code to open the connections to RabbitMQ, etc. And that would become a very, very, very large file that's basically too big to fit on this slide. So now I can finally fit it on slides, so this helps a lot already. And so we have this example extractor, and so the next step is basically we take it and we start testing it. So I start Clowder, I wait, I use Docker because it makes life easy. I wait for the full stack to be up and running, Mongo, RabbitMQ, and Clowder. I start my extractor. I could do that in my development environment. I'll upload the test file to Clowder. I see the message come into the extractor, see the extractor run, hopefully, and hopefully it comes all the way correctly to a finish, and then I go back to Clowder. The disadvantage of this is clearly that to be able to even do a very first type of testing, I need to bring up this whole Clowder stack, and I have lots of dependencies that I need to make sure that are working correctly. And so we started thinking about it, and we want to make it simpler. So, simple extractor. What can we do to make this easier? We removed the last little bits of boilerplate code. If you look at if we go back quickly to the example here, you can see that I need to create a new class, I need to extend it, and I need to write this extra function for processing the message. And in there, I need to do some work, like getting the file name and returning and uploading the data back to PyClowder. And I think we can do better than that again. So we want to get rid of those last little 3 pieces, and we want to simplify the testing of the extractings. We want to remove the requirement for you to test that you need to have Clowder or PyClowder installed. We want you just to be able to call the function with a file and look at the results that you get back. So to do that, we need to first say, how are we returning the results from the simple extractors? So they need to return a very well-mapped list of results. So in the middle, you can see the result that you need to return. It's a JSON-like object. In Python, it would be a dict. Other files could just return in JSON. I'll talk about that in a second. And it's basically showing the metadata that needs to be returned. Notice how I talk about lines, words, and characters, which map directly to the context that is in the extractor info. And that is critical because that basically is how we're going to basically be able to do the mapping of the results that are generated by the simple extractor and returning them back to Clowder. So this is the sort of contract that I want to make, is saying that for the simple extractor to work, this is what you need to return, this simple dict JSON-like structure. So how do we build the simple extractor? We provide a file or multiple files with the actual code. There are no dependencies of Clowder at this point anymore. We create the extractor info. Now, you had to create this before already, so that doesn't really change. And you create or copy this simple Docker file that sits on the right. And that is all that's needed to get the simple extractor to work in Clowder. Notice how basically the Docker file basically is the from and to environment variables that you specify. What is the extractor function and what is the extractor module that you want to use? What is the file that you want to call? So if I look at an example, here is the full file for a simple extractor. You can see there's a simple function at the top, word count, that takes a file's argument, does the processing, and generates this metadata result at the bottom that is being returned. The nice thing is at the bottom, and there's an error there, but I need to fix that. You can basically say, if the main function, just call it the word count function. And so you can write this piece of Python code and run it without any dependencies, and this is where my error sits there, any dependencies on PyClowder. So you could just call word count and have it run and print out the result and see what the result is. And so you can test this over and over again until you have your code working as you want it to be, without actually depending on any of the Clowder environment that is needed. Once you're done, you basically take this Docker file, create a Docker image, and put it into the whole Docker stack. At that point, your piece of code has become automatically an extractor without you having to do any additional work. So you do not have to worry about how do I connect to Clowder, how do I talk to Clowder, or anything of that. We do that all behind the scenes by leveraging off this contract that we signed with you. We're given a file, this is the result you need to return. So a simple extractor in Python to help you, because some of the code that you write might require additional packages, Debian packages to be installed. So you can have a packages.apt. This is a list of packages that will be installed. These are installed first by Docker. Next, your Python code might have requirements. So if you have requirements.txt, you list all your Python dependencies in there, and they will also automatically be installed. And then next, it will copy all the Python files and extractor info that you have into a folder. So the nice thing is, really, because of these steps that are done automatically for you, you can have your Docker file be this simple. Like, you do not have to have a much more complex Docker file. So this basically is all that's needed to get yourself up a simple extractor in Python. The other one that we've made is a simple extractor in R. It follows the exact same logical piece where you write your code in R. And as you look at this here, this is the exact same. This does a word count as well. It's exactly the same again. It's a function that takes a file as an input and returns a list, in this particular case, as output back. But it's the exact same format again. It's a list with the metadata, which is another sub-list with the lines, the words, and the characters in there. So I do not have to do anything. It's still the same contract that we had as before with the Python simple extractor. Behind the scenes, there's a little piece of helper code that basically calls this R function for you and takes the result that you return and basically serializes it into JSON, and then uses the same exact Python code to deserialize it and send it back to Clowder. But again, so hopefully with this, now you can just have this function, and you can do a simple test of this function whenever you feel like it. And when you're done, the exact same Docker file that we had before can be used, and basically you can wrap the whole thing up as a image that then can be used in Clowder. Same thing again for the simple extractor. You can have a package as apt, which lists all the extra Debian packages you might need in your code. You can also have a docker.r, which is a script that gets called, which contains any R packages or anything else that you need to do while the Docker file is while the image is being built. So this is sort of where you can do any additional. You can use the package.install to install any extra R packages that you require. Once you're done, it will copy. Once those steps are done, it will copy all the other files as well as the extractor info again, and package the whole thing up as an image that basically can be added to your Clowder stack. So hopefully this is sort of helps you basically not have to focus anymore on how to write my extractors, how to interact with Clowder, but you can really start focusing on the specific, what does my extractor need to do, and makes it simple by basically saying, and your extractor will only take a single file as input. So you're given a file, generate the results you want, and that's it. You don't have to worry about that much anymore after that. So as always, we have the Clowder framework, and the URL that sits underneath it is the URL to PyClowder, which has some of this documentation as well on how to create these extractors, and specifically at the bottom of the README, how to create simple extractors as well. Great questions.
Thank you, Rob. So we have plenty of time for questions or comments. We have a bunch of developers here as well. I'll make one comment and / question for Rob to clarify. So one of the things that you saw Rob present is that contract of the output being this dictionary that has this metadata in it. So what that means is that, if you remember what he said at the beginning, was that Clowder, when a certain event happens, a message goes out, and an extractor can pick it up. Well, what extractors in general can do is a lot of different things. The core thing that they do is add this metadata to the file or the data set. Mm-hmm. And so maybe if you want to comment about the fact that this simplifies that aspect, and there's the previews aspect, but it doesn't cover other type of activities that you might want to do as part of the extraction process.
Right. So it's called a simple extractor because we've noticed that a lot of the extractors that we write, like Luigi said, actually go and will take information and generate this metadata information that is needed. Some extractors might do more complex things and might not fall in the simple extractor category. But hopefully they can still leverage off the PyClowder extractors framework. to basically do more complex things. So for instance, if you want your, based on the file, add something specifically to a data set, or want to create a smaller, add tags to a file, or things like that, those don't fall right now in the simple extractor yet. And so those you will have to use the extractor. So in this particular case, really what we've tried to focus on is make it simple to add additional metadata based on the files that are uploaded, or, and I didn't show any examples of that, but you can also add previews to it. So if you, at the bottom here, you can see previews. It's a list of array file names, and those will basically just be added as previews to the particular file. So this way, it's also an easy way for you to take the code and say, given this file, generate a quick preview and return that preview back as a preview image to Clowder.
Cool. At some point, we might add more functionality to it. So for example, a really common pattern is you get a bunch of files and you output one aggregate or multiple aggregates, and all these derived files is something that right now you can do with PyClowder, but you cannot with the simple extractor in PyClowder.
The other thing that we've played with, so right now we have the simple extractor for Python and R. I think the pattern that we followed for the R extractor fits nicely to Java or other languages, and so we could easily add simple extractors for other languages as well, so that way you can write a couple of Java files or create a jar file, add it to that, and we will call the right function in there, and so you don't have to worry about connecting to Java or to Clowder from Java.
Cool. All right. Thank you, Rob. Thank you, everyone, for joining us today.